In this video lesson, we will talk about the area of a regular polygon, and specifically how to calculate it. So, first let's talk about regular polygons. Here's a regular triangle, which is also called an equilateral triangle. For quadrilaterals, it's a square. For five-sided figures, there's a regular pentagon. What all of these have in common is that each side has equal length in the figure, and each angle has equal measure. So that is what a regular polygon is. And the question is how to measure the area or calculate it. For a square, the answer is really easy. If you have, for example, side length 4, then you just take the square. The area equals 4 squared, which is 16. The case of a triangle is also not too difficult. But when you start getting into shapes bigger, like a pentagon, then everything gets complicated. Even the triangle isn't that easy. So, we'll talk about this by solving an example. Specifically, what is the area of a regular hexagon of side length s? So I'll label this side length s. It's equal on every side. And the strategy, and this works not just for hexagons, but for all sorts of figures. First of all, we know that since it's a regular hexagon, that each interior angle is 120 degrees. And the strategy is to take the central point and connect it to all the vertices. So we form these triangles. And these triangles are all actually equal. They're the same, they're congruent triangles. And each of these lines cuts the 120 degrees into two. So it cuts it into 60 and 60, which is really nice. We get this symmetry. So now these triangles are the same, so it all comes down to calculating the area of one triangle. And the rest of the triangles are the same, so we just have to add them together. Since there's 6 of them, the area of the hexagon is equal to 6 times the area of one triangle. So area of hexagon is 6 times area of triangle. So now all we gotta do is find the area of a triangle. And this strategy works for any sort of regular polygon, because you can still find the central point and form these sorts of triangles. So now we're just gonna look at only the triangle. Here we have it. It's got side length s, and we know that it's equilateral, so it's got side length s on all 3 sides. And we're going to calculate the area of this triangle. Now there's all sorts of ways of doing that. And in our case, one easy way, since we know all 3 sides and all 3 angles, is just to use the sine area formula. For better understanding of that, you can look at my video with that name, the sine angle formula, the sine area formula. So we get 1/2 times s times sine of 60 degrees. And sine of 60, this one we're doing without a calculator. We're just going to write it as root 3 over 2. Sine of 60 degrees is root 3 over 2. So you don't have to worry about knowing that, but some calculators are smart and they'll tell you that. But anyway, that's the area of one triangle. Now the area of the hexagon is 6 times that. So 6 times s squared times root 3 over 4. And that equals to 3 root 3 over 2 times s squared. So that is our answer. That is the area of a regular hexagon of side length s. So you might ask, how does this work on something that's not a hexagon? Well, here's, for example, I'm drawing a small octagon. We can still take the central point, connect the vertices, and get these small triangles. Now there's 8 small triangles. Just calculate the area of one, and you have the area of the whole figure. But anyway, thank you for watching this video lesson. I hope it helped.